students, welcome all of you. Today we will start a new chapter, that is electromagnetic radiations. It is full on theoretical chapter. So I will use notes, okay? So full on theoretical. ठीक है. यामध्ये असं conceptual किंवा formula और numericals असं काही नाही आहे. फक्त एकच formula आहे and rest all of theory. Okay, it is the last chapter of the first part of physics, that is part 1 physics का last chapter, electromagnetic radiations. Electromagnetic radiations. Okay, electromagnetic radiations. Now see the laws which describes the electromagnetic radiations are Gauss law. We have studied these laws. Faraday's law. Then Gauss law we have studied in electrostatic as well as in magnetism. So Gauss law of electrostatic and Gauss law of magnetism, then Faraday's law and Ampere's law. Faraday's law we have studied in electromagnetic induction. That is the induction of electricity because of motion inside the magnetic field. And Ampere's law we have studied in magnetic effect of electric current. That is solenoid, toroid. Okay. Now this law describes the generation of electromagnetic radiations, electromagnetic waves. Then, so we can say electromagnetic waves based on these laws. This is the first point. Next point, in 1885, Henry Hertz invented electromagnetic waves. 1885 Henry Hertz. Then based on, and in all we can say he explained reflection, refraction and interference. Reflection, refraction and interference of electromagnetic waves. So this is about Henry Hertz. So Henry Hertz na 1885 मध्ये electromagnetic waves invent केल्या and he described reflection, refraction and interference of this wave. Then Indian scientist, that is Jagdish Chandra Bose also studied and he produced the electromagnetic waves of higher wavelength. Higher wavelength electromagnetic waves produced केल्या Jagdish Chandra Bose, but his study was limited to laboratory only. तिथून तो बाहेर त्याचा स्टडी येऊ शकला नाही, म्हणजे it is not accepted by scientific organizations. So in 1895, Indian scientist, that is Jagdish Chandra Bose produces waves, electromagnetic waves of wavelength 5 nanometer to 25 nanometer. So he produces electromagnetic waves, produced electromagnetic waves of wavelength 5 nanometer to 25 nanometer. But his study was limited up to the laboratories only. तिथून तो बाहेर येऊ शकला नाही. Then G. Marconi. So this is the history of electromagnetic waves. G. Marconi. He is from Italy. Italian scientist, Italy, in 1896, 1895, 1896, 1885, 1896. Now he is the pioneer of wireless communication. He is the pioneer of wireless communication. Pioneer of wireless communication. Wireless communication. Why wireless communication is required? Wireless communication, whether for costing, radio, television, or telephone, now cellular, that is mobile, so radar, so all are wireless communication systems. Now for this he got Nobel Prize. Nobel Prize for telegraphy, telephone, and broadcast. Okay, so now this is the history of electromagnetic waves. So these three scientists are important, that are Henry Hertz, Jagdish Chandra Bose, and G. Marconi. So Henry Hertz invented the electromagnetic waves. Then Jagdish Chandra Bose produced the waves of wavelength 5 nanometer to 25 nanometer. And G. Marconi, he is from Italy. He is called pioneer of wireless communication system, because wireless communication system is one of the most useful technology nowadays. From 1990s, in telephone or telegraph, then television, radio. Okay. Now we'll see the electromagnetic waves consist of electrostatics and magnetism. That means consist of electricity and magnetism. So if accelerated charge is moving in this direction, that is the direction of electromagnetic wave. In which the accelerating charge is going. Now simultaneously there are two types of waves. Both are vibrating in transverse. So electric wave is also vibrating transverse, and magnetic wave is also vibrating in transverse. But the difference is, suppose the electromagnetic wave is traveling in x direction. Suppose it is traveling in x direction. This is x direction. That is the direction of electromagnetic wave. Electromagnetic wave direction. Then this is the direction of, suppose this is y-axis, x-axis, y-axis. So electric waves or electric field is in the y direction. Y direction म्हणजे vertical plane, I suppose. So here x from left to right, y from bottom to top. Then z direction कोणती असणार? Left to right, bottom to top. Then z direction will be back to front. So back to front will be the z. This is in horizontal plane. This is the horizontal plane. back to front. This is back to front. This is bottom to top, and this is from left to right. Left to right, back to front, bottom to top. Okay, so this is from back to front, front to back, back to front, front to back. So we can conclude that all the three, that is direction of electromagnetic waves, electric field and magnetic field, all are perpendicular to each other. All are perpendicular to each other. Why? Left to right, this is front to back, and this is bottom to top. All lines are perpendicular to each other. So we can say the electric field and magnetic field are perpendicular to each other and vibrate transverse to direction of electromagnetic waves, as well as it is perpendicular to electromagnetic waves. Direction of electromagnetic waves. That means all three are mutually perpendicular to each other. So this is the direction of electromagnetic waves. So electromagnetic waves consist of electric field and magnetic field. This we have studied in wave optics also. That is waves based on electromagnetic radiations that consist of electricity and magnetism. Okay. Now one by one we will see what are the characteristics of electromagnetic waves. Characteristics of electromagnetic waves. So you just remember 3 points here. The electromagnetic waves are produced due to accelerating charge. Electromagnetic waves are produced due to accelerating charge, and the direction of electromagnetic waves is perpendicular to the direction of electric field as well as magnetic field. Or electric field and magnetic field oscillates, or they are transverse to direction of electromagnetic field, electromagnetic wave. Okay, now we'll see what are the characteristics. Characteristics of electromagnetic waves. Electromagnetic waves. So the full chapter is of theory. You will have only one formula. So point 1, electric field and magnetic field are always perpendicular to each other. Are always perpendicular to each other, and also to the direction of propagation of wave. That I have told you. The electric and magnetic field are perpendicular to each other as well as to the direction of electromagnetic wave. So the first point, the points are very conceptual and logical, so no need to bug up the points. You just study analytically. It's very interesting part. Now next point. Okay, now as these three are perpendicular to each other, we can say E cross B will be direction of electromagnetic waves. E cross B, that is the vector product. Vector product in the vectors we have seen, when two vectors are mutually perpendicular to each other, then their vector product will be the vector which is perpendicular to the initial vectors. So we can say the second point, vector E cross vector B gives the direction of electromagnetic wave. Or again we can say E cross B gives the direction of energy carried by electromagnetic wave. Nothing but same. Energy carried ची direction. That means direction of propagation. ज्या direction मध्ये ती जाते त्यामध्येच ती एनर्जी घेऊन जाणार आहे. ओके. नेक्स्ट पॉइंट. E and B vary sinusoidally and are in phase. See, both waves are sine waves. Both electric wave and magnetic wave are sine waves. And these waves are in phase. बघा 0 ला 0 आहे, 90 ला 90 आहे, परत 0 ला 0 आहे. ओके. क्रेस्ट ला क्रेस्ट आहे, ट्रफ ला ट्रफ आहे, याचा ट्रफ ला याचा ट्रफ आहे. कारण हे टॉप आहे तर याचा फ्रंट आहे, याचा बॉटम आहे तर त्याची बॅक आहे. सो टॉप ला फ्रंट, बॉटम ला बॅक. म्हणजे काय? दीज आर इन फेज. फेज. कोणती वेव्ह पुढे पाठीमागे आहे का? नाहीये. सगळ्या वेव्हज काय सोबत जात आहेत. सो वी कॅन से दैट दीज आर इन फेज. Very sinusoidally, sine wave आहे. Next, electromagnetic waves produced by accelerated charge. So these are produced by accelerated charge. Next, EM, electromagnetic waves, can travel through free space. As well as through solid, liquid and gas. In free space, now see, electromagnetic waves can travel through free space as well as through solid, liquid and gas. Light जर consider केली तो light cannot travel through opaque medium. Opaque, transparent मधून light pass होते. So light is a form of electromagnetic wave. It is not the electromagnetic wave. It is one form. That form cannot travel through the opaque medium. It can only travel through transparent medium. But electromagnetic waves can also pass through the opaque medium. बघा तुम्ही एखाद्या घराच्या आतमध्ये आणि तरी पण तुम्हाला तिथे नेटवर्क येतं फोनचं. म्हणजे फोन मोबाईल साठी जी नेटवर्क लागणार आहे ते भिंतींना क्रॉस करून येतं. घराच्या वॉलचं किंवा तुम्ही मोबाईल बॅग मध्ये ठेवला असेल तरी पण रिंग होतो. कारण सॉलिडला पेनिट्रेट करू शकतात वेव्हज. सो दीज कॅन पास थ्रू सॉलिड, लिक्विड as well as gases. In free space, EM travel with speed of light. So in free space they will travel with speed of light, and the formula is C is equal to 1 upon root mu naught epsilon naught, where mu naught is permeability of free space, and epsilon naught is permittivity of free space. Free space is nothing but a vacuum. This value is 4 pi into 10 raised to power 7 minus 7 Tesla meter by ampere. Tesla meter by ampere. This value is 8.85 into 10 raised to power minus 12 Coulomb square by Newton meter square. Okay. Now the next point. In any other medium. Now see, this mu naught and epsilon naught are the permeability and permittivity respectively for the free space. That is when the medium is vacuum. But if this electromagnetic waves is traveling in water or in solid or any other medium, then the permeability and permittivity of we have to take of that medium only, that is mu and epsilon. So we can say in any other medium, C is equal to 1 upon under root mu into epsilon, where mu and epsilon permeability and permittivity of that medium. Okay. And next point. Ratio of magnitude of electric field and magnitude of magnetic field is C. That is, ratio of magnitude of electric field upon magnitude of magnetic field is C, which is nothing but 1 upon mu naught by epsilon naught. This is also very important point. These are all practically observed things. As electric field is more prominent than magnetic field, it is responsible for optical effect. So it is called light vector. Now see, electric field is more prominent than the magnetic field, because when there is a current, then only there will be the magnetic field. When there is a flow of charges, then there will be the current, and if the current is there, then there will be the magnetic field. But for electric field, no need of flow of charge, no need to flow of current. Even though the charge is stationary, there is an electric field. So electric field is a prominent thing. जर इलेक्ट्रॉन जर मूव होत असेल तर तो ॲडिशनल पॉइंट असेल. चार्ज फक्त असला तरी पण इलेक्ट्रिक फील्ड असणार आहे, आणि चार्ज जर मूव होत असेल तर त्याच्यामुळे इलेक्ट्रिक फील्ड येणार. सो इलेक्ट्रिक फील्ड इज प्रॉमिनंट than the magnetic field, hence it is responsible for the optical effect. So it is called light vector. So out of E and B, E is called light vector. And then intensity I, because of electric field, is half epsilon naught E naught square. This is electric field, this is permittivity. The intensity because of B is half B naught square upon mu naught. And last point, the energy is distributed equally among E and B. That's why IE is equal to IB. This is not the current. This I is not the current. I, E and IB are the intensities. Okay. So these are the very important characteristics of electromagnetic waves. This you have to remember. Logically you can remember. पहले तो simple है. Electromagnetic fields are perpendicular, also perpendicular to electromagnetic waves. त्याचा क्रॉस प्रोडक्ट घेतला तर काय मिळणार आहे? थर्ड डायरेक्शन मिळणार. That is the direction of electromagnetic waves. These are sinusoidal and also in phase सोबत जातात. These are produced by accelerated charge, that is the cause. Electromagnetic waves can travel through free space as well as through solid, liquid and gases. तुम्ही तो मोबाईलच्या नेटवर्कचा एक्झाम्पल घेऊ शकता किंवा रेडिओचं एक्झाम्पल घेऊ शकता. घरामध्ये रेडिओ आहे तरी पण आवाज येणार आहे. भिंतीमधून वेव्स येतात. असं काय नाही की ते घराला ओपनच पाहिजे टेरेस. The travel with speed of light. This is the formula. This is one of the formula which is important in this chapter. What important म्हणजे तो एकच आहे. ठीक आहे. Next we'll see what is electromagnetic spectrum. Write down all the points. Now spectrum, we need to draw the diagram. So electromagnetic spectrum is the chart which shows the different types of waves. On the left hand side or on the right hand side there are two properties, that are the frequencies and wavelengths of respective waves, and that is the comparison chart. Okay, so I draw here. This is with your visible light. So here it is 10 raised to power 15, 10 raised to power 10 raised to power 20, 10 raised to power 25. Here it is 10 raised to power minus 15, 10 raised to power minus 10, 10 raised to power minus 5. This is frequency mu. Here it is wavelength lambda or wavelength lambda in centimeters. These are in centimeters. Okay. Now here 10 raised to power 10, 10 raised to power 5 and 1, 10 raised to power 10, 10 raised to power 5 and 1. Now up to this region, this is ultraviolet. From here to here, this is X-ray. From here to here, this is gamma ray. Okay, ultraviolet ray. Then from here to here, infrared rays from here to here, microwaves or radar waves from here to here, television waves or radio waves, television waves or radio waves. So on left hand side of the spectrum, the scale is of frequency. On right hand side, it is of wavelength. This middle portion is of visible light. This middle portion is visible light. Visible light that we can see with our naked eyes. That is VIVGYOR. Okay. So we can see the ultraviolet rays. Violet is having highest frequency. So above the violet, the frequency is highest. That is gamma rays, very high frequency. Compared to that, radio waves are of very low frequency. But when we talk about the wavelength, we know red is having highest wavelength. So red, infrared, red मतलब infrared ना. So इथं असणार बघा सर. VIBGYOR. Okay. After violet, ultraviolet. After red, infrared. Okay. So red is highest wavelength. After that, infrared. Then microwave, that is called radio waves, radar waves. After that, television waves or radio waves. So this is the sequence of all the waves. Okay. We can change here radar and microwave. If comparison is honest. So draw this chart. This is called electromagnetic spectrum. Electromagnetic spectrum. Okay. Now, after drawing this, we will discuss all the properties and uses of all these rays, and this is what our chapter is. Okay. We will see one by one. First of all, we will start with radio waves. Radio waves. So these are produced by accelerated motion of charges in conducting wire. Wire मध्ये charge conduct होत असेल, then these waves are produced. The frequency depends on the inductors and capacitors. Okay. So we can say produced by accelerated motion of charges in conducting wire. So it is produced by accelerated motion of charges in conducting wire. Frequency depends on, next point, frequency depends on inductance and capacitance. Inductance and capacitance we have seen in electromagnetic induction. Capacitance is denoted by C, inductance is denoted by L. On these two, the radio waves frequency is depending on. So by using suitable inductor and capacitor, we can achieve the desired frequency. आपल्याला जी डिझायर्ड फ्रिक्वेन्सी आहे ती अचीव करायची असेल, सो वी हॅव टू यूज द सुटेबल इंडक्टर अँड कॅपॅसिटर. सो वी कॅन ॲड थर्ड पॉइंट by suitable inductance and capacitance we will get desired frequency. Okay, now we'll see what are the properties of radio waves. So they are having very long wavelength, okay, from few centimeters to thousands of kilometers. See, you can see here the wavelength, chart of wavelength. It is having very large wavelength. This is in centimeters. So 10 raised to power 10 centimeters means 10 raised to power 8 meters. 10 raised to power 8 meter means 10 raised to power 5 kilometers. So lakhs of kilometers. So it is having very large wavelength. So you can say it is having very, first property, they have very long wavelength. Very long wavelength. Very long wavelength. From few centimeters to 1000 kilometers. Now, inside the radio waves there are different frequencies. That is frequency of AM, frequency of television, frequency of FM. We'll see it is from 530 kilohertz to 1710 kilohertz. See, FM is AM, Akashwani, government channel, that is having very less frequency. But FM seems to be very clear. FM चा आवाज क्लियर येतो आकाशवाणीचा, हा तर किंवा मोठा येतो. सो ऍक्च्युली AM चा आवाज क्लियर येतो आणि FM चा मोठा येतो पण थोडासा फरक येतो. सो AM मध्ये काय असतं, वेव्हलेंथ जास्त असते बट फ्रिक्वेन्सी कमी असते. सो इट इज 54 megahertz for TV to 890 megahertz for television, 88 megahertz to 108 megahertz. So these are the frequency range for applications of radio waves in different transmissions. That is AM, amplitude modulation, television and frequency modulation. AM, Akashwani. FM is FM, 98.3 radio frequency. Okay. Now, what are the uses? So we'll see one by one what are the uses of radio waves. So uses: wireless communication, radio broadcast, television broadcast, cell phones. So there are lots of uses. So wireless communication, military purposes. Okay. So uses of radio waves. I can म्हणू शकता wireless communication, then radio, TV, mobile. These are the uses. Now we will see the second type, that is microwaves. the microwaves. Microwaves. So these microwaves are produced by Henry Hertz, and these are produced by oscillator circuit. Oscillator, LC oscillations we have seen in electromagnetic induction chapter. One capacitor and one inductor is connected in the series. Okay, that is LC oscillations. So it is based on the LC oscillations, inductor and capacitors oscillations. So that produces microwaves. Also by special vacuum tubes. Okay, so how these are produced? Produced by scientist Hertz, Henry Hertz produced microwaves. Produced by oscillator circuit containing capacitor and inductor. Capacitor and inductor. And also by special vacuum tube. Okay. Next are the properties. So this is only one point about microwaves. Next we are going to see the properties. Properties used for they heat the certain substances on which they are incident. So this is the property we have seen in the micro ovens. Micro ovens generally we use in our kitchen. Okay, काही तुम्ही पफ असेल किंवा काही बिग स्टफ असेल और पिझ्झा असेल तो बनवण्यासाठी तुम्ही काय यूज करता? मायक्रोवेव ओव्हन यूज करता. They can be detected by crystal detectors. So these are only two properties. They heat certain substance. Students, sorry for some technical issues. So they heat certain substance on which they are incident. So ज्या substance वरती हे पडतात तो substance गरम होऊन जातो. So this is one of the useful property in cooking. They can be detected by crystal detectors. So they can be detected by crystal detectors. So these are the two properties. Now we will see what are the uses of microwaves. Used for TV signals. Again, these can be used for TV signals. Then for long distance telephonic communication, long distance telephony communication, long distance. Ovens for cooking. Then radar system for locating distant object like ship and aeroplane. So distant object कुठेतरी दूरवरती शिप आहे किंवा एरोप्लेन आहे ते डिटेक्ट करायचं असेल तर we use microwaves and to study atomic and molecular structures. To study atomic and molecular structure. I know तुम्हाला बरोबर होत असेल कारण का पुन्हा theoretical chapter आहे, but still don't worry. वेटेज असं खूप कमी आहे आणि जरी क्वेश्चन्स आले तरी theoretical असते. Next we will see third type of waves. That is infrared waves. Infrared waves. Now infrared waves are somewhat useful and somewhat dangerous. Let's see what are their uses and how they are dangerous for us. So all hot bodies emits the radiations. आपण बघितलं radioactivity मध्ये. So these are infrared rays. So around 60% of solar rays containing infrared rays. सोलर रेज मधून जे येतात रेज त्यापैकी 60% काय असतात इन्फ्रारेड रेज असतात. सो we'll write all hot bodies are sources of infrared rays. Are the sources of infrared rays. 60% of solar energy is infrared. Thermocouple, thermopile, bolometers are used to detect infrared rays. So these are the devices which are used to detect the infrared rays. So most of the part of the solar energy consists of infrared rays. Now when it falls on any object, the objects get heated. This is also a property of infrared rays. ही सुद्धा एक प्रॉपर्टी जशी मायक्रोवेव्ह ची होती तशीच कोणाची आहे इन्फ्रारेड वेव्ह ची आहे. सो इट इज स्ट्रॉंगली एब्सॉर्ब्ड बाय ग्लासेस. ग्लास याला एब्सॉर्ब करतात. ग्लास गरम होते बिकॉज ऑफ infrared rays and they can penetrate thick columns of fog, mist and cloud cover. So clouds ना ते कव्हर करू शकतात. फॉग आला तर ते म्हणून आता काही गाड्यांच्या हेडलाइट्स आहेत त्या विंटर डेज मध्ये किंवा एकदम कोल्ड स्टेशन मध्ये आपण यूज करतो किंवा विमानामध्ये ज्या लाईट्स असतात त्या दॅट आर इन्फ्रारेड रेज. का तर तिथे काय होतं ते क्लाउड्स ना पेनिट्रेट करू शकतात आणि तुम्हाला दिसू शकतं. सो त्यासाठी त्या लाईट असतात. सो वी कॅन से what are the properties incident on object it will get heated. So if it incident on object it will get heated. कौन object short मध्ये लिहिलेले strongly absorbed by glass, then they can penetrate thick column of fog, mist, cloud cover. So they can strongly penetrate thick column of. So it is very easy for us to see during foggy day, or we can say when there is a fog or mist on the roads, or while flying the aeroplane. Now next we'll see the uses of infrared rays. Uses. So there are lots of uses. Uses खूप जास्त आहे त्याचे. Used in remote sensing. Used in remote sensing. Remote sensing. So तुम्ही जो रिमोट कंट्रोल यूज करता है तो सुद्धा infrared rays चा यूज केला जातो, ठीक आहे. Then diagnosis of superficial tumors and varicose veins. Now superficial tumors असतील तर तो चेक करण्यासाठी याचा यूज केला जातो, डायग्नोसिस करण्यासाठी. Then varicose veins हा डिसीज मोस्ट ऑफ द टीचर्स लोकांना होतो. टीचर्सना कंटिन्यू उभं राहून शिकवायची सवय असते. सो जो नीच्या खालचा पोर्शन आहे जे बोन आहे तिथे ज्या वेन्स असतात त्या वेन्स हा आहे बघा, ही थाय हा नी आहे, हा पाय, हा नी आहे, नी ही थाय. इथल्या ज्या वेन्स असतात, इथं तुम्ही शूज घालता, इथं सॉक्स घालता, या वेन्स असतात त्याला म्हणतात व्हेरिकोस वेन्स. आणि या शिराच्या आहेत क्लॉटिंग होतं. कारण का तुम्ही खूप वेळ उभं राहिलेला असतात, टीचर्स लोकांना मोस्टली होतात, आणि ब्लड तिथे येऊन काय होतं, ॲक्युमुलेट होतं म्हणजे साठलं जातं आणि तिथं क्लॉटिंग होतं. आणि infrared rays are used to diagnosis that superficial tumors and varicose veins. So to diagnosis superficial tumors and varicose veins. Then to cure infertile paralysis and to treat sprains, dislocations and fractures. Sprains, dislocation and fractures. See, lots of uses are there. Dislocate होता है एखादा हार्ट किंवा फ्रॅक्चर होता है एखादा बोन. सो डिसलोकेशन मध्ये काय होतं, जॉइंट डिसलोकेशन, बोन फ्रॅक्चर in this case, or in paralysis, varicose veins. Varicose veins is nowadays very dangerous problem. Okay, solar water heater and cooker. Solar water heater and cooker. So solar cooker and solar water heater. So they uses 60% of solar energy is there na, and it is infrared rays. And infrared rays is used for what? Heating. मग तुम्ही असं म्हणू शकत नाही की उरलेल्या 40% मुळे हीट झाली असेल बॉडी. कारण सन सोलर एनर्जी मध्ये 60% इन्फ्रारेड आहे. मग बॉडी जर हीट होत असेल तर ती कुणामुळे होते, तर या 60% मुळे होते. का होते, तर 60% ची काय आहे प्रॉपर्टी, हीट करते. Then spatial infrared photographs, spatial infrared photographs of the body or thermographs thermograms called thermograms can reveal diseased organs because this part radiate less heat than healthy organ. So can reveal diseased part or organ because diseased organ radiate less heat than healthy organ. Now special photographs are there. If you take the photograph or machinery when in the industry there are some special cameras where infrared photography is used. Why? If you take a photograph of any machine, then it will show the temperature variations. Which part is more heated, which part is less heated, so that the worker it will be very easy for a worker to handle the parts. कोणत्या parts ला कोणत्या tool न ऑपरेट करायचं आहे, कोणत्या डायरेक्ट हात लावला तो पार्ट गरम असेल तर तुम्हाला कसं कळणार तो गरम आहे. सो देयर इज अ कॅमेरा, त्याच्यामधून जर तुम्ही बघितलं तुम्हाला वेगवेगळ्या कलर्स मध्ये डिफरंट पार्ट दिसतील. नॉर्मल बघितल्यावर काहीच दिसणार नाही, पण कॅमेऱ्यामध्ये बघितल्यावर तुम्हाला दिसणार की हा जास्त लाल दिसतो म्हणजे हा जास्त गरम आहे. असे डिफरंट कोड्स आहेत. सो इथं तसा त्याला म्हणतो आपण इन्फ्रारेड फोटोग्राफ्स. आता एखाद्या बॉडीचा फोटोग्राफ घेतला तर आपल्या ऑर्गन्स आहेत, एखादा डिसीज्ड ऑर्गन आहे, एखादा हेल्दी ऑर्गन आहे. हेल्दी ऑर्गन विल रेडिएट मोर हीट than the diseased organ, so that will be captured in photograph, so we can judge if the problem hai. Then next use is infrared binoculars. So there are some binoculars also. See, infrared waves are very important. Infrared rays, binoculars and thermal imaging cameras are used in military applications for night vision. Used to keep greenhouse warm. Then used in remote control and TV VCR. Okay, remote sensing. इधर पण होता है, इधर पण होता है. So remote control का remote sensing is different. Okay, remote control. Now here greenhouse, okay. ग्रीनहाऊस मध्ये काही वेस्टर्न कंट्रीज असतील जिथे टेम्परेचर खूप कमी असतं आणि व्हेजिटेबल्स काय केलं जातं, एक फार्मिंग केलं जातं. अँड फॉर दॅट सपोज त्या व्हेजिटेबल्स इंडियामध्ये ग्रो करणारे असतील, दॅट आर स्पेशली मीन फॉर इंडिया. बट इफ इंग्लंड और इंग्लैंड पीपल और रशियन पीपल और अंटार्कटिका पीपल और ऑस्ट्रेलिया पीपल, they want to grow such type of farming, but the atmosphere is not suitable, there is a cold weather. So what they do, they use greenhouse effect and the infrared rays which are captured. What is the property of infrared rays? It will heat the substance on which it will fall. So the greenhouse is made in such a way that when rays enter into the greenhouse, it will not return back to the atmosphere. So it's like ozone layer or heavy gases which absorb the heat. सो तिथं हीटिंग पर्पज साठी याचा यूज होतो आणि त्यामुळे ग्रीन हाऊस मध्ये आपण त्या कोल्ड ॲटमॉस्फिअरला इंडियन व्हेजिटेबल्स और ट्रॉपिकल व्हेजिटेबल्स सुद्धा आपण तिथं लावू शकतो. बट व्हाट इज बायनॉक्युलर्स अँड थर्मल इमेजिंग कॅमेराज आर यूज्ड इन मिलिटरी ॲप्लिकेशन्स. सो एखाद्या जंगलामधून रात्री जर पाकिस्तानच्या लोकांनी किंवा एनिमी कंट्रीने जर घुसखोरी केली म्हणजे इंडियामध्ये यायचा प्रयत्न केला तर जंगलामध्ये सगळ्या फॉरेस्टमध्ये सगळ्या ट्रीजचं टेम्परेचर अराउंड सेम असेल, बट कोणी पर्सन जर पळत असेल तर तिथलं टेम्परेचर काय असणार आहे, त्या पर्सनच्या बॉडीचं टेम्परेचर इज मोर दॅन द सराउंडिंग ॲट द नाईट. During the night, the temperature of human body is greater than the temperature of the surrounding. So त्या कॅमेरामध्ये तो स्पॉट रेड दिसत असणार आहे. कोणता तरी हॉट ऑब्जेक्ट इज रनिंग or coming inside our body, or we can say LOC, line of control. So त्याच्यासाठी याचा यूज केला जातो. So these infrared rays is very important. Next we will see visible light. Now, no need to talk more about visible light because we have whole optics on visible light. Ray optics, wave optics. Okay, most probably the optics, wave optics. So, visible light. This is the fourth visible light. Detected by human eye. The first property is detected by human eye. Not by any instrument, but first of all by human eye. Although they are detected by instruments, emitted due to atomic excitation. Emitted due to atomic excitation. Properties. Different wavelengths are because of different colors are because of different wavelengths. So different colors are because of different wavelengths. This we have studied. Dispersion of light. Reflection gives vision. Yeah. Reflection gives vision. Reflection gives vision. Now when light falls on any object and reflects back to your eye, it will give the proper image of that object on your retina. So that's why reflection is needed. Okay, so this much is enough for visible light. Baki, you know all VI, VGYOR. Violet is having highest frequency, lower the wavelength. Red is having larger wavelength, less frequency. Red is strong color. सगळं तुम्हाला माहिती आहे. So this is visible light. Now we'll see next fifth. Ultraviolet rays. Ultraviolet rays. Similar to infrared, this is also dangerous as well as it is useful. Produced by now mercury vapor lamp. Produced by mercury vapor lamp. Electric spark. Electric spark or carbon arc lamp. Carbon arc lamp. These are the sources. Striking electrical discharge. Striking electrical discharge in hydrogen and xenon gas tubes. Sun is most important source. Sun is most important source. Sun is most important source for three: infrared, visible and ultraviolet. लागून आहेत ना ती पण रेडच्या खाली इन्फ्रारेड, वायलेटच्या वरती अल्ट्रावायलेट. Most of the UV rays absorbed by O3 layer. Most of the UV rays absorbed by O3 layer. This O3, this ozone is called a good ozone because it is in the atmosphere. There are some in stratosphere, mesosphere, stratosphere. So it is called good ozone because it will absorb the ultraviolet radiations and will not send it to the earth, which will avoid the skin cancer or any hazardous diseases. But the ozone produced near to Earth's surface because of the pollutants, that is bad ozone, that will increase the temperature of our Earth, that is called global warming. And that ozone is produced because of NOx emission, NO2 emission, because of the automobile pollution, automobile emission, diesel engine emission or petrol engine emission, NOx production. NOx is the products of nitrogen oxides. Now the properties of UV rays. Properties. They produced fluorescence in certain material such as phosphorus. Produces fluorescence. We have seen this fluorescence in gamma rays. They cause photoelectric effect. Causes photoelectric effect. Why? आता विजिबलच्या ज्या खालच्या लाईट्स होत्या त्यामध्ये तसले इफेक्ट काय दिसले? कारण का त्यांची फ्रिक्वेन्सी कमी होती, स्पीड कमी होती. यांचा फ्रिक्वेन्सी जास्त आहे, स्पीड जास्त आहे, तर यामध्ये फोटोइलेक्ट्रिक इफेक्ट वर दिसतात. They cannot pass through glass but through quartz. Okay. Cannot pass through glass but passes through quartz, fluoride and rock salt. Vitamin D. Now we'll see uses. What are the uses of UV rays? So uses. UV rays destroys germs and bacteria, hence they are used for sterilizing surgical instruments and for purification of water. This is the main important use. Okay, so we can say sterilizing surgical instruments and for purification of water. used in burglar alarm. Burglar alarm for security purposes. I have told you burglar alarm in photoelectric effect. Burglar alarm. तिथे या रेटचा यूज केला जातो. Then used to distinguish. This is the also important use. Used to distinguish between real and fake gems. Gemstones असतात ना, gemstones ज्वेलरी म्हणू शकतो आपण. तर रिअल आहे की फेक आहे ते बनवण्यासाठी यूज टू अनालाइज केमिकल कंपाउंड्स. टू अनालाइज chemical compounds. To analyze chemical compounds. Now, the remaining is X-ray, which I have told you. We will discuss it later on. X-ray, gamma rays we have already discussed during alpha, beta, and gamma. We have discussed that three rays in nuclei chapter. Nucleus chapter मध्ये आपण बघितलं आहे nuclear physics मध्ये कि gamma काय आहे. So gamma rays we are not going to discuss over here, that we have already discussed. So we just discuss X-rays. X-rays, gamma rays सगळं तुम्ही बघितलेलं आहे. ठीक आहे. Now this is the sixth X-rays. It is discovered by Rontgen or Rontgen. That's why it is also called Rontgen ray. So X-ray is nothing but stream of electrons. Stream of electrons. So you can call it as stream of electrons from cathode in vacuum tube. In vacuum tube. It can be stopped by, it can stop suddenly, it can stop suddenly by obstacle. Now the properties. They are high energy electromagnetic waves. Obviously, as frequency is high, we can say energy is equal to h mu. As frequency high, energy will be high. High frequency substances, high frequency waves, X-ray, 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 gamma ray. Okay, so we can say these are high energy electromagnetic waves. High energy waves, not deflected by electric field and magnetic field. Chargeless, not deflected by electric field and magnetic field. They ionize the gases. Ionize the gas. बघितलं हे पण आपण. High penetrating power, near about same that of the gamma. High penetrating power because of high frequency. High penetrating power. Then their overdose can kill the living plants and animal tissues. So dangerous to living plant and animal tissues. So these are dangerous for them. इथं बघितलं जातं बघा तुम्ही जिथं एक्सरे काढला होता हॉस्पिटलमध्ये तिथे एखादा पर्सन if he is suffering from some injury, then only X-rays are passed through his body because already वो injured है, so तिथं ते necessary है X-ray pass करना का to detect where is the fracture or all, but विनाकारण एक्सरेच्या समोर जाऊ नका सांगतात. It will harm you. Now what are its uses? Uses to study structure of crystal, to study structure of crystal, then X-ray, bone fracture, CT scan, bone fracture, CT scan. Okay. Then flaws, cracks in metals, flaws, cracks in metals. So these are the defects in metals. एखादा मेटल आहे त्याच्यामध्ये काही void राहिलेला आहे का ते बघितलं तर मेटल समजा मोल्ड केला, मोल्डन स्टेट मध्ये मेटल तुम्ही एखाद्या कॅव्हिटी मध्ये पुट केला आणि परत you have wait for solidification. Due to cooling it will solidify and you will get the solid metal. आता त्या solid metal मध्ये काही एअर बबल मुळे काही डिफेक्ट राहिलाय का तो आपल्याला चेक करायचा असेल तर we use X-ray. Detection of explosive, detection of explosive. So this is about all the rays. Gamma rays we have already studied during alpha and beta, and gamma, all the three rays we have studied in nuclear, and this is the end of the chapter. This much only. That is the last chapter of first part of physics, 12th class physics. Okay, that is electromagnetic radiations. Full theoretical chapter, no need to worry, only 2-3 marks chapter, 2-3 marks weightage. And now because of COVID हे पण केलंय की थोडासा सिलेबस पण रीड केला तर आणखी वेटेज कमी झाला असणार आहे. डोंट वरी अबाउट दिस, जस्ट रीड दिस चॅप्टर बिफोर गोइंग टू एग्जाम. ओके, थँक यू व्हेरी मच.